we're graphing f of x, and there will be some sort of fraction, right? So you could get numbers with variables in the top, variables in the bottom, no variable in the top, but there will be always a variable in the bottom at least. So we always start by seeing if we can factor and simplify. So that's step one. See if you can factor both the numerator and the denominator, and see if you can simplify. If you can simplify, if you can cross out a variable in the denominator or an expression in the denominator, then there's a hole. Where whatever you cross out equals 0. So if I cross through an x plus 1 in the top and x plus 1 in the bottom, then I would do x plus 1 equals 0, and I would get that the x is negative 1. So you always set it equal to 0, and that's the x value of your hole, okay? If you have a hole, that is the only thing you get from your original, and then everything after it, you use your simplified fraction. If you cannot factor and simplify, then we start to do our asymptotes. The vertical asymptote comes from setting the denominator equal to 0. And then we solve and we get x equals for our vertical asymptotes because they are lines and they are vertical lines. For the horizontal asymptotes, we look at the exponent in the top, highest exponent in the numerator, highest. And that's your n, and then the highest exponent in the denominator, and that's our m. If n is less than m, then the horizontal asymptote is y equals 0. If n is greater than m, then there is no horizontal asymptote. That's it. Looks like a J. That's a semicolon. Let me put an arrow. And if n is equal to m, then we do y equals the leading coefficient of my numerator over the leading coefficient of my denominator. And these are all y equals equations because they are horizontal lines on your graph. We look and see if there's a slant asymptote. And for these, the n is 1, only 1, more than m. And this we'll practice today because we didn't get to it yesterday. But if there is a slant, you find it by dividing the numerator by the denominator, setting your quotient, whatever you get on the top, equal to y, and ignore the remainder. This will also be a y equals, but it will be y equals mx plus b. It will be a line because the slant asymptote is going to be a line with slope. Then we did our X-Intercepts, so you want to pay attention to the words. If it says X-Intercepts or zeros or roots, those all mean the same thing. They all mean set your numerator equal to 0 and solve for x. If it asks for intercepts, you'll put it in coordinate point form. So it would be whatever you get, comma 0. If it asks for roots or zeros, you'll just list the number. So I'm pretty sure on the quiz I put X-Intercept, so it would be in coordinate point form, but you'll see this both ways. And then comes the Y-Intercepts. And for these, we plug 0 in for x. And this would be in a coordinate point form.
For the holes on the quiz,
God bless you. Yeah, the coordinate point form.
and you have to plug basically that hole back into the equation.
Correct. Into your new equation after you cancel through. Could be. Yeah. Especially the X-Intercepts, because we want you to just not only use your graphing utility, but you're going to have to give those X-Intercepts. You wouldn't be able to find them from the chart that way. So you'll get at least some that are not, they're not fractions, or they're not, I mean, they're not whole numbers, and they're not fractions that are like a 0.5. I think there's one in there. If not, I'll definitely add one on there. Was that your question? Yeah, okay. All right, so that's kind of like wraps it all up, okay? In general, questions on rational expressions can ask for domain. I didn't put it on the quiz, but for domain, you just set your denominator not equal to 0. So you have a restriction based on the bottom not being 0. That would be domain. And domain, when you look on your graph, like from left to right, you'd skip all the spots that have vertical asymptotes. So again, like if you just happen to like, want to go on the internet and find some extra practice on rational expressions, they might ask you for domain, okay? But I didn't put it on the quiz.
When it's like n is equal to n,
Yes.
what's the LCM?
Leading coefficient, so the number on the front of the one with the highest exponent.
Okay, thank you.
You're welcome. Sure. What's different with this one? You can factor it. This becomes x plus 3, x minus 3, x minus 3, x plus 1, and x minus 3 cancels out. So a vertical asymptote, horizontal asymptote, slant asymptote, hole. This time I've got a hole. The hole comes from wherever you canceled out being set equal to 0. So if x minus 3 is equal to 0, then the hole happens where x is 3. That is the only thing I get from my original equation. Everything after this, I use y equals x plus 3 over x plus 1 to answer. Yep.
Do we just put 3?
No. I'm going to now find the y that matches. Was that your question too?
But how do you know if it's x or y?
It's always the x. Yep, because you're crossing through x minus 3, so x equals 3 is where the hole is. So now to find the y coordinate of the hole, I am taking 3 and I'm plugging it back into my updated equation. So again, the only thing you get from the original is the x value of your hole, and now I'm done with the original. I use everything after this on the updated. So if I plug 3 in here, I get 3 over 2, or 1 1/2, and that's the y coordinate of my hole. Now, yep. To the updated one, yep. Vertical asymptote comes from the new denominator, so x would equal -1. Exponent in the top and the bottom are the same, so this is a leading coefficient scenario. Y would equal 1 over 1, which is 1. No slant. X-intercept comes from my updated numerator, getting set equal to 0, which is at -3, 0. Y-intercept comes from plugging 0 in to my updated equation. And then I'm going to plot those. All right, so before I even use my graphing utility to figure out my curves, I'm going to plot all the stuff I already know. So a vertical asymptote at -1 means I have a vertical line through -1. A horizontal asymptote at y equals 1 means I have a horizontal line at y equals 1. There was no slant. There is a hole at 3 1/2. Did we do the 1 1/2 together? Okay, good. So there's a hole there at 3 1 1/2. So I literally go to 3, let me get a darker color, and 1 1/2, and I plot a circle. So 1, 2, 3, 1 1/2. There is a hole here, which means my coordinate, like my curve has to pass through there, but that open dot means it would be empty at that exact spot because it would be undefined at that graph. -3, 0 is my X-intercept. So I've got -1, 2, 3 here, and 0, 3 is my Y-intercept, which is here. So I don't even need my graphing utility because I know if it's crossing through here that it has to be in this corner, and I know it's crossing through here and has to cross through but leave that open space in here, that it's in those top 2 quadrants. So this is a scenario in which You could use your graphing utility to check, but you don't even need it. So because I know it goes here, I'm going to draw it. Again, it gets close enough to the X-intercept, vertical asymptote and horizontal asymptote without touching it. It ends in those arrows. And then the one in the top right quadrant, it's going to do the same thing over here, but through here it actually has to stop and start again because you can't cross it through that hole. So that's what a hole looks like when you draw it out. When you graph this on a graphing utility, you will not see that hole. So remember, you have to be smarter than your calculator with this stuff. You won't see the asymptotes and you won't see the holes. You'll see the curves, but that's it. So when I graph this on my graphing utility, I'm graphing my updated equation, the one after I canceled out. Actually, it wouldn't matter. Your calculator would figure it out to cross it out. But so I'm going to plug in x plus 3 inside parentheses divided by x plus 1. And then I hit graph. Say again? Oh, I put it at 4. This should be 3. Thank you. Put it too high. So it should be there. Not there. Okay, and then notice that it does not show the hole, right? It doesn't show the hole. It doesn't show the graph. If I go to table, it even looks like there's a point at 1.5. Like it's in my list on my table. So be really, really careful with the holes, okay? You would have to say that there is a hole there at that 3 and 1.5. So every question, and there's 4 of them, every question has all of those blanks. Vertical asymptote, horizontal asymptote, slant asymptote. If there's none, you put the word none. Hole. If there's none, you put the word none. But if there's a hole, then you have to make sure you give me the coordinate point for that hole. And then you have to show it on the graph. Questions?
We're going to have undefined, right? Like undefined ones, like this word names or something like that.
Like there's no X-intercept? Yeah, and you would just write none. Yep. Or okay, so we didn't do 5. What are you going to do first with 5? Factor out the x in the top. So I can take out an x, and I get x times x minus 1 over x plus 1. Can something cancel? No. So there's no hole, right? If it was both pluses or both minuses, then I would cancel. But right as it is, you can't cancel, so there's no hole. So if I'm starting my list, vertical, horizontal, slant, hole, there is none. Accent, Y-Int. All right, so vertical asymptote. Now I go to my denominator. I set this equal to 0. X would equal -1. Then I look at both my numerator and my denominator. I look at the degree. So what's the degree in my numerator? 2 in the denominator? 1. What scenario is this? It's 1 more, so there's a slant. So there's no horizontal, because remember, you can't have both. If it's in the bigger in the top than the bottom, there's none for horizontal. But there is a slant asymptote. So we have to take and divide, and I divide the original. I divide x squared minus x by x plus 1. 2 options. Because this is x plus 1 on the bottom, I can actually use synthetic or I can use long division. So I'll walk you through both so you remember, because it's been a little bit, okay? But in both scenarios, you have to check to see if you're missing anything, right? And look at the top. We're missing the constant. So I would write x squared minus x plus 0 divided by x plus 1. So I'm going to do long division first, and then we'll review synthetic. This is first into first. So what would I have to multiply x by to get to x squared? X, I multiply it times both. I get x squared plus 1x. And then I change my signs. The first column cancels, as it should. And then I get negative x minus x. So this is negative 2x plus 0. First into first again. So what do I have to multiply x by to get to negative 2x? Minus 2 gets multiplied by both. So negative 2x minus 2. And then we change our signs. This cancels as it should. Now the difference is if this was just straight up division, I would make note of my remainder. With a slant asymptote, we completely disregard the remainder. It doesn't matter. It is of no use to us in finding slant, okay? So as long as these first ones cancel out, I don't even need to acknowledge the remainder. What I need is here at the top. That x minus 2 gets set equal to y, and that is my slant asymptote. So it should be a line because it's got a slant asymptote, and it should be in y equals mx plus b format. Now, because what you're dividing by here is just an x, right, not an x squared. If it was x squared, we could not do synthetic, and if it is x squared in the bottom, we couldn't do synthetic. But we can this time. So I'm going to list all my, so I take this x squared minus x plus 0, and I list all my constants and coefficients, 1, -1, 0. I put that long L-shaped bar, and I put the opposite of what follows x on the outside, so this would be -1. Bring down the 1, multiply it by -1, put it in the next column and add it, multiply it, put it in the next column and add it. I don't need the last column because it's my remainder. The -2 stays the constant, the 1 gets the x, and we set it equal to 0. Equal to y, sorry. And there's my slant asymptote. So you get to choose which of those you want to do.
So if it was x squared minus 1, you would be able to do it?
Correct.
Sorry, x squared plus 1.
X squared at all in the denominator, and you can't do synthetic. Synthetic is only if it's x plus or minus. Yep.
So if it is x squared, we could do
Correct. All right, now X-intercepts. My X-intercepts come from my numerator. So I can either use the one that I originally have, or I can factor it because I'm going to have to eventually anyways. If I stick with the original, I set it equal to 0. I would end up factoring out the x and then split and solve this. And I get x equals 0 and x equals 1. That means I have 2 X-intercepts, one at 0, 0 and one at 1, 0. The Y-intercept comes by plugging 0 in for x, and you can plug it in here or in its factored form, it doesn't matter. I'd get y equals 0 squared minus 0 over 0 plus 1, 0 over 1, which is 0, which is consistent with an X-intercept of 0, 0. Questions so far? Okay, now we plot all our information. So vertical asymptote at x equals -1. No horizontal asymptote, but this time there's a slant. My slant asymptote is y equals x minus 2. This is just a y equals mx plus b equation. So I start where? Start at the b, right? What's the b? -2. So I go to -2. And my slope is 1, so I go up 1 and over 1 or down 1 and left 1, and I would draw my slant asymptote. So when you have a vertical and a slant, they always crisscross like that. They're going to make some sort of an X, okay? Either skinny, wide, whatever it is. And from here, when you have a slant and a vertical, it's like having one horizontal and one vertical. Your curves will always go in opposite corners. There has to be 2. So there could be one here and here, or there could be one here and here. So because I have other information, I'm going to plot the rest of that. My X-intercepts are at 0, 0, and 1, 0. And my Y-intercept is at 0, 0, so I've already got it there. So what corners do we think this is going in? The top right, bottom left. So I think it's going to look like this and like this before I even get to my calculator. Now I let my calculator confirm it. So y equals x squared Yep.
Which is the one that you have to put the arrows on?
The purple, these.
This is Roser?
Yeah.
On the quiz, is the factoring just like simple factoring this, or is it like completely square and like factoring everything like that?
There could be, you could, not completely square, but there could be ones with a coefficient on the front, like if there's like 2x squared, we have to do first and last. You could see something like that. They won't all be like that, but there could be something like that. Mm-hmm.
So it's just like grouping.
You could see factor by grouping. I didn't put one on your quiz with factor by grouping, but you could see it. Like, I can't remember if there's one in the homework or not. But it's, I mean, you gotta just make, it could be any kind of factoring. Like, I didn't do sum or difference of cubes or anything like that, but you could see them in practice of rational equations. All right, so there's my graph, which is consistent with what we just found. Bella.
Yesterday, I thought you said that nothing could pass the vertical asymptote.
It's not passing, like it can't cross through it.
Yeah. But isn't the slant?
Oh, the asymptote can, the graph itself cannot.
Oh, okay.
Yeah. They have to intersect in order to give you that like little spot to put your curves.
On the quiz, is there any, I mean, the quiz review, is there an example where there's any numbers on the, when you're factoring in front of the equations?
If there's not, I will find one for you. I'll look at it today. Yeah.
So it's basically just like if there's a 2
You know, like if it said 2x squared,
minus x plus 1.
2x squared minus 3x minus plus 1, like that, right? And over x squared, let's say it's minus 1. So I'd have to factor the top, right? So this I could do first times last, so 2 times 1, factors of 2, that sum to -3, -1, -2. And you'd get 2x squared minus x minus 2x plus 1, factor by grouping. Take out the x. Take out the -1. And my numerator factors to that, right?
Yeah.
Denominator, difference of 2 squares. So this is a scenario in which you'd have a hole. Okay.
And what was that x equals?
The hole would be at x equals 1, and then I would take the 1 and plug it back in. To get the y coordinate of the hole.
Seems like it's the one that's simplified.
The only thing you get from the original is the x coordinate of the hole, and then you are done with the original.
Okay.
Everything else comes after it. All right, let's do this together. This is 6. Step 1 is factor it. How do I factor x squared minus x minus 2?
X minus 2 x plus 1.
Good. X minus 2, x plus 1. Does something cancel? No. So I know no hole, right? So vertical, horizontal, slant, hole, none. X-intercept, Y-intercept. Now I go vertical asymptote. Set my denominator equal to 0, x equals 1. Horizontal asymptotes. Highest exponent in the top, 2 in the bottom. So this is a no horizontal, but there is a slant. So I have to do x squared minus x minus 2 divided by x minus 1, or use synthetic. 1, -1, -2. Outside goes a positive 1. Bring down the 1. I ignore the remainder. My b is 0, and I get 1x. So this is y equals just x. If you want to do x plus 0, that's fine.
Can you do it through long division?
Yep. Oh, do you want me to like work it out? Yeah. X squared minus x minus 2 divided by x minus 1. So the first one be x. Multiply it out. Change your signs. Cancels. And so does this. I'd end up with 0x minus 2.
So it's okay, that'll cancel out.
Yep. It would be a 0 here. 0x plus 0. And then it changes. This we totally disregard as long as these are gone, which they would be. I just set that equal to 0. So I've got my slant at y equals x. Now I need my x-intercepts, so I set my numerator equal to 0. I already factored it, so I might as well just use that. I get x equals 2 and x equals -1. And then from my y-intercept, I plug 0 in for x. I get 0 squared minus 0 minus 2, so -2 over 0 minus 1, -1, and that's 2. You would just do -1 and 2. You wouldn't put them in coordinate point form.
But would you put x equals or just the number?
You just list them. Actually, it doesn't, if you want to put x equals, you can put x equals that one, comma, that one, so they're not separate equations, then it's fine.
Okay.
Yeah.
Do you know which one it'll ask for?
I think I put X-Intercepts on the quiz.
So like,
Yes. I will make sure, because I'll double check on those instructions, I'll double check and make sure the quiz review matches the wording on the quiz.
thank you.
You're welcome. Okay, so vertical asymptote is x equals 1. There's no horizontal. My slant is y equals x, which means my b is 0 and my slope is 1. So I start at 0, 0. I go up 1 and to the right 1. My x-intercepts are at 2, 0 and -1, 0. And my y-intercept is 0, 2. So where do we think this curve is going? Good. Top left, bottom right. Put it on the calculator. All right, there we go. Again, should match it. Kira.
What is it, when it's a slant, does it also have to be like dotted, like dashed?
The slant asymptote is dashed.
And then does it also get arrows?
I mean, technically, all the asymptotes have arrows because they're lines that never stop. I'm not going to nitpick on the arrow on the asymptote as long as you've got them on the curves.
But they have to be dashed.
The asymptotes, I mean, again, when you're drawing it like on your quiz, I don't need you to go back and like erase your, you know what I'm saying?
Yeah.
You could draw your lines.
Okay.
Yeah. And I'll even give you colored pencils if you want to make them pretty, go for it. It'd be very entertaining for me to grade when they're pretty. But know that in the, you know, in the existence of what you're drawing, those are asymptotes. They wouldn't appear as solid lines. Like they don't even appear on my graphic utility. Those are, the answer to this graph is actually the curve and not the asymptotes, but you need the asymptotes to get the width of the curve.
Yeah.
Does that make sense?
Yeah, yeah.
Okay. All right, last one. Can you factor the? No. Okay. So I know nothing's going to cancel out. Well, let me do vertical asymptote first. Vertical asymptote, horizontal asymptote, slant asymptote, whole. There is none. X-int, Y-int. Okay, vertical asymptote comes from setting my denominator equal to 0, and I don't even have to solve anything. There's my vertical asymptote. Look at your exponents, top and bottom. What's the relationship? Top one is 1 more, so no horizontal asymptote. And there will be slant. So I can do 3x squared plus 0x. I need that placeholder. Plus 1 divided by x plus 0. Again, I need that placeholder. Or I could do 3, 0, 1 and put 0 on the outside. There's no sign for 0, so it doesn't matter. Bring down the 3, multiply it times 0, put it in the next column, add it. Do it again. We ignore the remainder. The b again is 0. The 3 gets the x. So this would be y equals 3x. And again, you could put y equals 3x plus b, which would be plus 0 if you need it, but you do not need the 0. If I had used the long division, this would have had to be 3. This would be 3x. Sorry, this would have to be 3x. 3x squared plus 0x. Change your signs. These would cancel. 0x plus 1 plus 0, 0x plus 0, and these would cancel. And there it is again. Set it equal to 0. Set it equal to y. So you could do either one.
Interesting that the zeros, yes, they make all that work.
No, because you don't need the remainder. If it was a regular division problem in which I needed the remainder, I would make sure I would keep going because there's a remainder here. But because we're ignoring it, you can stop as soon as you see those line up as zeros. All right, x-intercept. So this time if I set 3x squared plus 1 equal to 0, I can't factor it. If I subtract the 1, I get 3x squared equals -1. X squared would equal -1/3, and I would try to square root a -1/3, which gives you what? an I, so there's no real solution here. So there are no X-intercepts because there's no I's on your graph. If, let's say that numerator was something that couldn't be factored, but it had 3 terms, what would you do? Quadratic formula. So if you can't factor it and there's 3 terms, like I said, 3x squared plus 5x plus 1, you would have to do the quadratic. If the quadratic results in an I, then you have no, which I think is one of the ones in the homework like that, then there's no X-intercepts. But if it does result in something like 2 plus and minus the square root of 3 over 4, those are technically X-intercepts, okay? I won't do that to you on the quiz, but know that that could happen because those are technically real numbers. They'd be hard to find. You'd estimate them, but you can find them.
When do you do the quadratic?
If it was something when the numerator has 3 terms, but it's not factorable. All right, then last thing is your Y-intercept. So I'd get 3 times 0 squared plus 1 over 0, and I get 0 plus 1 over 0, which is undefined. What does that tell you? There's no Y-intercept. So it's not crossing either axis. My vertical axis, asymptote is at 0. My slant is at 3x. So I'd start at 0. I'd go up 3 to the right 1 or down 3 and to the left 1. Now think about it. It doesn't touch this axis. It never touches this axis. It never touches this axis. It never touches this axis. So although I have not a single point to plot, where do we think it's going? And the little slivers that are up and down. If it didn't, if I plot it here and here, I would have to have X-intercepts, right? But I don't, which means it's going to have to go in between here and here. Yep. Sure. What do you have X? Okay. It even like cuts off, so your guys, the ones that were having issues yesterday with like the picture, it might really cut yours off, okay? But it is consistent with what we drew. So in my opinion, the slants are easier to like figure out what the graph looks like because you know it's going in opposite corners and you usually have at least one piece of information to tell you what it looks like in those corners. You really want to rely on the calculator for a backup in those scenarios. The ones that have like 2, like you could have ones that have 2 vertical asymptotes. So there's a bunch of different kinds of graphs you could draw, but let's say you have 2 vertical asymptotes and then 1 horizontal. There are different patterns that can happen. This can go up, and this can go down like a parabola shaped, okay? Or the reverse. The ones on the outside can point down. The one in the middle can go up like a parabola shaped. Or you could have 3 asymptotes, 2 vertical and 1 horizontal. And this one goes up and down, and this one goes up to the right and down to the left, or all of that flips. So those are the ones that I would say, like, you're going to still have to give me X-intercepts and Y-intercepts, but you may need to rely on your calculator to know what those curves are doing. And there's patterns, but I don't need to stress you out with them right now. You could literally just use your graphing utility to help you when it gets time to that drawing. Questions for me on anything 4-2 related? Yep. Yes. The 4-2 is due tomorrow morning. I'll post the quiz review. I want to finalize it, make sure I get you the examples that you guys need. And then I have to take your quiz. So I'm going to take the quiz, watch the timing, and then go back to the quiz review, make sure that things line up. And then I'll post that for the weekend. That will have solutions, so it's not that you have to turn it in. But we will start 5-1 tomorrow, which is like exponential functions, very different from what we're doing. Not very different, but somewhat different from what we're doing now. Those will not be on the quiz, though.